445 million years ago, it took a continent the better part of 1,000,000 years to drift into the wrong spot and end 85% of life on Earth. 66 million years ago, it took 6 seconds. That's how long it took for a rock 10 kilometers wide, moving faster than a rifle bullet, to cross the last few hundred meters of atmosphere above what is now the Yucatan Peninsula and hit the ground. The headline is that an asteroid killed the dinosaurs. What that headline leaves out is what actually did the killing. Something slower, colder, and almost invisible that took years, not seconds, to finish the job. To understand what actually happened, you need to see what the planet looked like in the hours before impact, because the late Cretaceous world wasn't some primitive warm-up act to modern life. It was one of the most sophisticated ecosystems the planet had ever produced. Flowering plants had spread across every continent. Forests looked recognizably like forests. Dinosaurs weren't just surviving. They were still actively diversifying, tens of millions of years into their reign, with no sign of decline. Triceratops grazed in herds. Tyrannosaurus stalked the North American floodplains as one of the most efficient apex predators to ever exist. In the oceans, mosasaurs, the size of buses, patrolled alongside ammonites that had survived, essentially unchanged in body plan, for over 300 million years. This was not a world on its last legs. This was a world at the peak of its complexity, with no reason to expect anything was coming. And that's the detail to grab onto, because it's the same pattern the fossil record keeps showing. The late Ordovician seas were thriving right up until the ice sheets started growing. This ecosystem was thriving right up until a rock crossed the last 6 seconds of sky. Mass extinctions don't wait for a system to weaken. They just wait for the trigger. The object was roughly 10 to 15 kilometers across. Not enormous by asteroid standards, but moving at somewhere around 20 kilometers per second when it hit. The energy released has been estimated at the equivalent of several billion Hiroshima-sized bombs detonated in a single instant. The crater it left, now buried under the Yucatan Peninsula and partly under the Gulf of Mexico, is called Chicxulub, and it's roughly 180 kilometers wide. Large enough to swallow a mid-sized country. The impact triggered earthquakes strong enough to register on the other side of the planet, and tsunamis that some estimates put over 100 meters tall, smashing into coastlines thousands of kilometers away. Within minutes, everything within a vast radius of the impact site was dead. Vaporized, incinerated, or crushed by debris raining back down from an atmosphere that had briefly been turned into a furnace of superheated rock and glass. If the story ended there, this would still be one of the worst single days in the history of life on Earth. Most of the animals that died in the mass extinction weren't anywhere near Chicxulub. Many of them lived on the opposite side of the planet, thousands of kilometers from anything that could have felt the blast. Something else killed them. The impact didn't just release energy. It vaporized bedrock. Trillions of tons of pulverized rock, dust, and sulfur-rich material. and threw it directly into the upper atmosphere. Some of that material fell back to Earth as superheated debris, re-entering the atmosphere fast enough to ignite wildfires across huge stretches of the planet. But the finer material, the dust and the sulfate aerosols, stayed up and it spread. Within weeks, it had wrapped around the entire globe, and it stayed there for months, possibly years. Sunlight couldn't get through. And that single fact is the actual engine of this extinction, the same way ice albedo feedback drove the Late Ordovician extinction. Without sunlight, photosynthesis collapses. Not just on land, but in the oceans, where microscopic phytoplankton form the base of nearly every marine food web on the planet. Kill the plankton, and everything that eats the plankton starves. Everything that eats the things that eat the plankton starves after that. It's a famine that starts invisibly, in the water and the soil, and climbs its way up through every link in the chain. Global temperatures crashed. Some reconstructions suggest a drop of 10 degrees Celsius or more within a matter of months. An impact winter arriving almost as fast as the impact itself, just spread out over a longer, crueler timeline. Photosynthesis on land is estimated to have shut down almost completely for at least a year. In the oceans, the collapse of plankton populations gutted the base of the food chain for even longer. This is why the asteroid itself isn't really what killed the dinosaurs. The asteroid killed everything in its immediate radius in minutes, but 3/4 of all species on Earth, including every non-avian dinosaur, every mosasaur, every ammonite that had survived 300 million years of history up to that point, died over the following months and years, starved by a sky that had gone dark. At almost exactly the same time the asteroid hit, on the other side of the planet, something else catastrophic was already happening. In what's now India, a region called the Deccan Traps was erupting on a scale that's difficult to picture. Not a single volcano, but a sustained flood of lava covering hundreds of thousands of square kilometers, releasing enormous volumes of sulfur dioxide and carbon dioxide over hundreds of thousands of years. Some of the most intense phases of that volcanism appear to cluster suspiciously close to the timing of the impact itself. That's led to one of the most genuinely unresolved debates in paleontology. Was the extinction caused by the asteroid alone? By the volcanism alone? Or, and this is where most current research is landing, was it a 1-2 punch with a stressed, already destabilized biosphere hit twice within a geologically short window? First by sustained volcanic climate disruption, and then by the sudden, catastrophic finishing blow of the impact? If that's right, it's an almost exact structural echo of the Late Ordovician. That extinction wasn't one event, it was 2 linked pulses, habitat collapse, then an oxygen crisis close behind it. This one may not be so different. A slow-burning volcanic stressor, and then a 6-second trigger that pushed an already strained system past the point of no return. The recovery from this event took a long time, even by the patient standards of deep time. Ecosystems didn't fully recover their pre-extinction complexity for hundreds of thousands, possibly millions of years. But recovery did come, and when it did, it opened a door that had been sealed shut for over 150 million years. With the dinosaurs gone, a group of small, mostly nocturnal animals that had been living in the margins for the entire Mesozoic era finally had room. Mammals. Within a few million years, they diversified explosively, filling niche after niche that dinosaurs had occupied for the entirety of their reign. That expansion never really stopped. It kept branching for tens of millions of years, and one of those branches eventually produced something almost nobody expects from this story. A second kind of human, walking the same earth as our own ancestors, that shouldn't have been possible by everything we thought we knew.